Hello, math fans. Several things I'm going to do here, but mostly I want to introduce you to the concept of congruences because there are many problems I have in my head that I want to talk about that require a basic understanding of what a congruence is. Now that sounds, I'm not talking about triangles, I'm talking about something from dealing with numbers. But the story I'm going to use is how my mom took money from her fourth graders. She's not going to be happy I said it that way. She didn't take money from her fourth graders. She played a game with them with pennies, and she provided the pennies, so she was winning her money back. But we'll get to that in a second. My mom was a longtime teacher at Union Gap School in the Yakima Valley. Students absolutely loved her. You know, she was a compassionate person that did so many things for so many students. Every year the principal would be like, we have these 5 students that nobody can handle in any of their classes. Let's give them to Mrs. Lovelace. She gets them all. And that's often a thing in teaching. The better you are, the more you are punished. But then those students would come back to her later and she would make a connection. I learned my love of games from her. I really never thought I would be a teacher, but when I went off to study graduate school, don't worry, I'll get back to the story here in a second. When I went off to graduate school, they made you teach, and I hated talking in front of people, and they forced me to do it, and students were happy, and I think that's just because of years of watching my mom. She taught me a lot about how to be a patient teacher because she was so good at it. And I think we all learned how to be fun and enjoy learning from her mom. So I found some pictures here. Grandma Penny was quick-witted, always enjoyed learning, always was so sweet. So we owe so much to her, and I owe so much to my mom. I found a few pictures. There it is. One thing about this picture is this is when my brothers and I agreed to all be fat. And I'm really mad because they've gotten skinnier, and this isn't as skinny as they are, and I've stayed fat, so I think it's really rude of them. My brother is a huge WSU fan, and the truth is I am too. So don't tell my UW students. I hope nobody sees this. I'm a big WSU fan. I love when I have students that are athletes at UW. I root for them above all else. But if it's UW playing WSU, I'm rooting for WSU. It was too great of a place to be when I was there in grad school. The community is wonderful. It's different. So there you go. Okay, so back to the story. I was talking to my mom, and I have many ideas relating to her, but I just wanted to get something out. So she mentioned several stories, and I don't think she knew I was going to take them this way. But she said one thing she said to her students, and this doesn't have to do with congruences, is she would say, go home and bet your parents $1 that you can flip them over without touching them. So she'd have her kids go home. The parents would say, all right. The parents would set $1 out, and they said, okay, I'm going to flip you upside down without touching you. And then the kid would go get a spoon from the drawer and have the parent hold up a spoon to their face. And if you've ever looked in the, what is that, the concave part of the spoon, you're upside down. And so she taught her kids how to steal $1 from their parents. That was not part of the story, but I'm embellishing. So then she would come to school, and the student would have that $1. This is not how it happened. And she would say, okay, now I want to play a game for that. Actually, she had a collection of pennies, and she would hand the pennies out, and she would have the student here. Let's call this the student. And then you would have my mom. Mom feels funny. She's the teacher in this situation. And she would say, we get this collection of pennies. See, I have a whole bunch of pennies over here. And I have a jar of pennies here. And here's the game. You get to keep all the pennies if you can be the first person to get to 20. So it's a fun little game if you're playing with kids. And she would say, well, since you're new to this, I'll let you go first. The only rule is you have to either put down 1, 2, or 3 pennies. Okay, so this student says, all right, I'll put down 1 penny. And then I have to do the same. And whoever's the person that says 20 first wins. So my mom would say, let's put down 3 pennies. So that makes a total of 4. Let's keep kind of a running total. And then the student would go, okay, I can put down 3. Nah. And make the total 7. Here, I should have said it was like this. And then she would say, I can't remember. Let's just do 1. She would get 8. And then they would say, I don't know what you're doing, but let's put down 2 this time just to mess it up. She'd say, well, that sounds good. 2 sounds good to me. Let's do that. So she'd be at 12, and this is at 10. And again, the person who says 20 wins. And so they went, we're getting kind of close, so I'm only going to do 1 this time. I'm worried she's got something up her sleeve. And she would do 3. And so then this would be 13. Just listen to me a little longer. So no one made it this far in the video. We all turned it off a long time ago. I know, I'm doing it for myself. And then you'd get to 16 and the person would go, uh-oh. If I put down 1, she's going to win. If I put down 2, she's going to win. If I put down 3, she's going to win. Darn it. And they probably would just throw the pennies. No, they wouldn't. But let's say they just put down 1, 17, and my mom would win. And she'd get to keep her pennies. She didn't actually steal from them. All the pennies would go back to her. And then she'd go to the next student, and the next student, and the next student, and she always won. And then the student would say, hold on, you always get to go second. That's not fair that you always get to go second. So she would say, okay, you go first. I'll go first this time. And she would put down 3, and they would put down 3, let's say. So let's see this game. So we're now at 6. Same rules. So she put down 3. They put down 3, so it made it 6. And they played the game again. So I'll play the game one last time. And then she said, well, I'll do 2. Make it 8. And then just stick with me here. And they're like, well, it's going to put down 3. Let's get to the end. It worked for her. She would then put down 3, 2, 3. No, I think actually she wanted to put down 1. Apologies. I forgot what I was teaching. And then they would put down 2, let's say, make it 14. And she would put down 2. And they would be like, oh no, I fell into the trap again. And again and again and again. And they really could never beat her, whether she went first or second. And at some point, a student would realize something, which is this person made a mistake back here. The mistake was whoever gets to 16 is going to win, which means whoever gets to 12 is going to win, which means whoever gets to 8 is going to win, which means whoever gets to 4 is going to win. So you want to make multiples of 4. And she would teach it as a divisibility problem. If you can always keep things divisible by 4, you're going to win because you're going to get to 20, which is divisible by 4. But when she's told me that story, I kind of never told her until I was talking to her recently, it makes me think of congruences, which are remainders. So if you do something like 7 divided, let's say 17 divided by 4, let's do some long division. Love long division. You get a remainder of 1. Well, if you're going to study divisibility, remainders become really important. So in math, we have a notation for this. We say that 17 is equal to, and we use this 3 line, and we call it a congruence, 1 mod 4. And some people have done computers, maybe have seen this. There's a button that finds the remainder. But this is a bigger thing. We're saying these are the same. In the eyes of 4, 17 and 1 are the same. In the eyes of, is there anything else that's the same? Well, how about 9? What would 11 be? Well, 11 would be the same as 3 mod 4. This takes some practice, but if you've done very much with numbers, and I've done just a little bit here or there, and it's part of research I've done, it becomes second nature. And then it becomes a really valuable tool in your ability to work with numbers. So what we say in math is when it comes to divisibility by 4, there's only 4 types of numbers. There's the group of numbers that are congruent to 0. There's the group of numbers that are congruent to 1. There's a group of numbers that are congruent to 2. And the group of numbers that are congruent to 3. And if you only had 4 pennies, the problem would be pretty easy, because you would say, I want to be the one that always hits 0. So if they pick 1, 2, or 3, I'll just make it hit 0 again. And a funny thing in this situation is if you do something like 3 plus 1, it's the same as 0. If you do something of 2 plus 2, it's 0. And that's all that's happening in this problem. Is you are keeping, every other time you're keeping it you're keeping it 0, remainder 0, divisible by 4. And they can't do that. All they can do is make it remainder 1, 2, 3, unless they go second. The person that goes second has the opportunity to seize the initiative and win. And she eventually had some students that would win. And that was the cheating. Not really cheating. My mom taught me to love lots of games. She's the one that I'm sure I have many videos on games. She also had fun acronyms for teaching things, and I'm thinking about how to incorporate those in the video. But this is a fun story you can do with your friends or kids or anything. Okay, so a natural thing here is, can we generalize to other numbers? And the truth is, there's nothing special here. You could pick something else divisible. You could play the 7 pennies game, where you can put down 1, 2, 3, 4, all the way up to 6 pennies. And then you'd be trying to and then let's say you were trying to go to 21, which is divisible by 7. Then you could play the exact same game. Whoever went first, let's say they pick 3, you're going to add 4. Then you're at 7. And let's say the next time they pick 5, you're going to add 2. You're still at a multiple of 7. Now you'd be at 14. So it's the same thing. We would call that mod 7. Okay, so studying congruence is really valuable, and there's a whole bunch of important examples. Just to be goofy here, if I said, what is 101 to the 500th power, and then ask if you were to expand this out in the calculator, what would your last digit be? So you're going to have this really long number. And I'm just asking what this digit will be. And the student will already know the answer just from looking at it, because they'll know when you expand this out, this has to be a 1. But there's a cleaner way to do that, which is to say 101 is the same as 1 if you divide by 10. So I don't know if this is the best example. I could have thought more carefully, and I'll do better examples in future problems. But 101 to the 500 is the same as 1 to the 500 if you're checking divisibility by 10, which is what you're doing when you're asking what the ones digit is. So the last digit is going to be 1. That's actually really valuable in the foundation of many algorithms that people use. And I'll finish this with what kind of got me thinking, as I had a friend last night who's in statistics say, sometimes he plays this game where he asks someone for a collection of numbers. So let's grab a few. I don't know, 2, 5. And you can make up your own numbers. He did it with 3 numbers. Let's do it with 4 just to show that it doesn't matter. So 2,537. If you've never played this game before, where you add the digits, let's see what we get. You get 2 plus 5. This is really important in checking for divisibility by 3 and 7. And I'll do a future video on this. But this is 10 plus 7, it's 17. And if you add those digits, it's 8. And that's the remainder if you divide by 9. It turns out you can just look at the digits. But he said, he had said a different thing to me, which I'd never really thought about it this way, which is, what if I just take the numbers and rearrange them into other numbers? Like, what if I have 53 and I add it to 27? Now, that's a different thing. That's not looking at the digits. It's like making just random other numbers from those 4 numbers. And then I add them together and you get 80. Then you add those digits together and you get 8. That is weird. Then he said, well, what if we arrange it some other ways? 732 plus 5. That's going to be 737. and then you add those digits and you get 17, and you add those digits and you get 8. And he was saying, you can just play this game all day, rearrange them into any 2 or 3 digit numbers, add them together, add the digits, you always get 8. So to keep watching, in a future video I'll talk about this. This really has something to do with 9 and its relationship with 10. But the number of topics I can talk about with this is enormous. I'm just trying to think about what are the most interesting questions. If you want me to do more videos like this, let me know in the comments. But I am going to talk about divisibility by 9, by 3, by 11, by 2, by 4, by 25, and many other things. But that's a small side topic, but just shows you the value of congruences. But mostly thank you to my mom for letting me joke about this. Again, she was just one of the most incredible 4th grade teachers. So many students talked about the impact they had on them. So many students that had struggled in school, she helped them get back on the path. People like that don't often get thanks. So my thank you to you for all you did for so many years, and for teaching me to love learning and have fun with it. So thank you. Love you, Mom.